G'day chemistry students. In this video, we're going to be doing another type of calculation that could be involved when looking at equilibrium constants. In this video in particular, we're going to be looking at calculating concentrations of substances that we already don't know the concentrations of based on their KEQ. Let's get into it. So in a scenario where you know the KEQ value for the temperature that your system is in, what you can do with that information is calculate the concentrations of some of the substances that are already sitting there in equilibrium. Something to note though is you can't just magically calculate all of the concentrations at equilibrium just with the KEQ value. It is still one of those things where we are limited by our algebra. So you can't have multiple or many unknowns. Usually you can only just calculate the concentration of one substance, possibly depending on the situation. You might even be able to calculate the concentration of two unknown substances, but you'll see that in the practice question today. We're going to be following a very similar set of steps. I'm going to read them out really quickly now and refer back to them when I actually go through the calculation. These steps will make a lot more sense when we actually go through the practice question that I have for you today. What we need to do first, like always, is identify the balance equation. We then need to write up an equilibrium expression as well. Once both of those things are done, like we do in pretty much any KEQ calculation, we can then start looking at the concentrations that we've been given. So if you are given any equilibrium concentrations, you can put them to the side pretty much straight away and have them in your back pocket for the substitution step a little bit later. Once we have our equilibrium expression, we know what values we actually know. What we then do is set the concentration of the unknown substance as a pronumeral. Usually I'll just use X. If you are able to solve for any other substances, either because the questions ask you to, or maybe because there is another substance in the equation or in the equilibrium that we don't know the concentration of as well, you may also have to write down an X value for it as well. But the value that you put is going to depend on the stoichiometry. Again, that'll make more sense in a moment. What we then do is substitute our X values into the original equilibrium expression. We can then rearrange the equation for X, and then we can substitute any of the known stuff that we have, as well as a KEQ value, and that will enable us to solve for X. Best way to do some of these questions is to actually look at it in practice, so let's get into that. All right, so for this video's question, we're going to be looking at the equilibrium between sulfur trioxide and its products, sulfur dioxide and oxygen gas. The question reads as follows. The following equilibrium is formed when sulfur trioxide gas is placed in a sealed container at 298 degrees Kelvin. And there we have our equilibrium. The equilibrium constant for this system at 298 degrees Kelvin is 1.26 times 10 to the negative 5. Once at equilibrium, it's found that the concentration of sulfur trioxide is 1.5 molar. Calculate the equilibrium concentrations for both of the reactants. Now, going in order for our steps, step number 1, identify the balanced chemical equation. That is what we are going to do first, and that is in the question. Second step is to write up an equilibrium expression. So we've already had some practice doing that. I'll write that up now. So KEQ is equal to the product of all products. First product that we have is sulfur dioxide. Because of the stoichiometry, it's going to be squared. Then we multiply by the other product, which is concentration of our oxygen gas as well. That's being divided by the product of the reactants. The only reactant that we have is sulfur trioxide. And we're going to square that because of its stoichiometry as well. Next thing that we need to do is identify or determine the concentration of all chemicals which have already been measured. Now there is only one that we've been given. That's one equilibrium concentration that we can substitute in, and that is for sulfur trioxide. Its concentration is 1.5 molar. So we'll be using that a little bit later once we've set out our equation and rearranged it appropriately. The next thing that we need to do is set the unknown equilibrium concentration as X. Now in this question, technically, we've been given two unknown equilibrium concentrations, and that is for both reactants. So that's our sulfur dioxide and our oxygen gas. So when you're trying to find the concentrations of two unknown substances, it's usually easiest mathematically to be working with the substance that has a 1 in the ratio of all of our substances. So because for our stoichiometry, there is 1 oxygen, we're going to be labeling that as X. So the first thing that I'm going to do is let the concentration of O2 be equal to X. From there, that will also mean that the concentration of our sulfur dioxide is going to be double. So we can make that 2X. Next step that we have is to substitute X values and rearrange for X. So that's what I'm going to be doing next. So once we know that O2 is X and SO2 concentration is 2X, we can put that into our equation. Note as well that this still has to be squared. So all I'm doing is changing out the concentration of the SO2 for 2X, but because this term up here is still squared, that stays. So we're going to keep that there. We now have a new equation, KEQ is equal to 2X all squared times X. And that's going to be divided by the concentration of our sulfur trioxide, which, not SO4, SO3, our sulfur trioxide, which we already know the concentration for. What we can now do is rearrange and solve for X. That's one of the last parts in this step. So what I'm going to do first is just put all of these X terms sort of together in the first step. So KQ is equal to, so when we square 2X, both of those parts need to be squared. That's going to turn into 4X squared. That's just some index laws that we should be familiar with from math already. We're going to multiply all of that by X and divide by the concentration of our sulfur trioxide square. Next thing that we can do is just put the X terms on the numerator onto one side and move everything else over to the other. So if I move up my sulfur trioxide, it's going to be KEQ times sulfur trioxide all squared is equal to 4X. And because we're going to multiply the X squared and the X together, that becomes X cubed. Now, next thing that I'm going to do is remove the 4 and the cubed from the side with X. I'm also going to just swap my left hand and right hand side too, so this reads a little bit nicer. So to get rid of the 4, I have to divide everything by 4. To get rid of the cubed, I have to put everything to the cube root. And I'm just going to put my KEQ and my sulfur trioxide concentration on the numerator there. If that algebra is a little bit intense or we're not too sure exactly how that's all happened, that is definitely something that we can go over and practice in class. But hopefully for most, that algebra is going to make a fair amount of sense there. Once we've done that, all we need to do is the last part of step 5, which is substitute all of the known concentrations and the KEQ value, and that means that we can solve for X. So we've already been given KEQ and the concentration of SO3 above. So the KEQ value, the only thing that we haven't got yet and then we haven't highlighted is there. So both of those values can go into our equation. So we can put 1.26 times 10 to the negative 5, multiply that by our concentration, which is 1.5, remembering that we also need to square that value. Divide all of it by 4 and take the cube root. So once that goes into your calculator, you should get the answer 0.0192 or thereabouts. If we're looking to match our significant figures, if we look at the top with all of our data, this only has 2 significant figures there. So I'm going to put that as 0.019. So X, if we remember, is the concentration of O2. And we also know that the concentration of the sulfur dioxide should be double that. So if the concentration of SO2 is equal to 2X, then that will be equal to 2 times 0.019. So I'll multiply that by 2. And I end up with 0.019. 0.038. And there we go. We've gone through a process to find the concentrations at equilibrium for a particular equilibrium system, given that we know its KEQ value. Thank you very much, everyone. In the next video, what we're going to start talking about is how we use KEQ as chemists. In particular, we're going to be looking at some groups of equilibrium systems that we're going to be deep diving into over the next 2 modules, as well as also looking at how industries are able to use equilibrium concepts to manufacture chemicals. But until then, have a good one.